Hey everyone, welcome to the first part in a 3-lecture series of Mastering Crypto. So I wanted to educate people who have heard about crypto, maybe have even bought some from an exchange like Coinbase or Robinhood, but don't fully understand quite exactly what this thing is and why it's getting so much attention. My mission is to teach you the most important concepts for mastering crypto quickly, because not only is it going to be relevant in your personal life, but we are currently on track to, within a decade, be living in a world where it is simply infeasible to prevent it from being an integral part of your life. And so this is something you are going to need to be prepared for. And I realize this is a bold claim. And so in an attempt to convince you of this, I've decided to take the 3 most important topics and break them into a series of educational videos. This is the first one, covering the understanding of blockchain technology. This is the underlying infrastructure that makes cryptocurrencies work. Second is understanding digital wallets, learning how they work, setting up your own personal wallet, and then sending and receiving crypto to your friends and family. That is the most fundamental and approachable application of blockchain technology. And then third and finally, I'm going to make a video on understanding Ethereum and why it, among all the cryptocurrencies, is the most powerful and impactful application of blockchain tech today. Now that said, let's focus today on our first topic. Now, cryptocurrencies are simply applications built on top of a novel and more general technology called blockchain. Bitcoin is an application of blockchain technology. Ethereum is an application of blockchain technology. Now, when it comes to understanding blockchain, there are about 9 steps to go through to understand what a blockchain network is and does, and we will be walking through those steps here. The mechanics may appear strange at first, so after explaining them, we will discuss why applications built on top of this technology have the potential to drastically improve and disrupt the global economy at the same magnitude as the internet did in the 21st century. Blockchains come in different flavors, but they all basically work in the same way. In this lecture, I'll be covering how Ethereum's blockchain works, because for reasons I will get to in part 3 of this series, Ethereum is by far the most powerful blockchain today. The first commandment is a blockchain is a protocol or set of rules implemented as open source software. So what is a protocol? Well, a protocol is simply an abstract set of instructions which are written with the intention of having interpreters implement those instructions in some concrete way. So for example, the US Constitution is a protocol or set of instructions for how the government should run, and then a concrete implementation of this protocol is carried out by our executive, judicial, and legislative branches. Ethereum is also a protocol, defined in its white paper written in 2013 by Ethereum's founder, Vitalik Buterin. In it, he outlines an abstract set of instructions for how this particular network is to run. Software developers then took those instructions and implemented software which obeyed these rules. To be clear, when you run Chrome on your computer, that is software. When you open your text editor on your computer, that is also software. An Ethereum protocol implementation is just another piece of software that can be downloaded and then run on your computer. The next commandment of the blockchain. This software, which we were just referring to, can be run on any computer, including your laptop. Each computer running the software is referred to as a node in the network. So I put the floppy disk here with the Ethereum logo next to each node here to indicate that each computer has downloaded the Ethereum software implementation and is running it on their machine. And in doing so, they are now contributing to the functioning of the Ethereum blockchain network. When this software is run, all nodes begin listening for incoming transactions on the network. Transactions for now you can think about in the same way as you think about a transaction of buying coffee at a coffee shop. The transaction in that case would be Bob sends $5 to Starbucks. It is a message that captures an event which, if successfully processed by the network, would update the state of the system. The new system state would show Bob's account as having a balance of $5 less, and Starbucks' account as having a balance of $5 more. Incoming transactions from external sources can enter the network by communicating with any node in the network. That is, any node in the network is a valid entry point for submitting a transaction. So just to show you an example, pretend this is my cell phone on the left. Let's pretend I have a crypto wallet app set up on my phone, which holds a balance of Ether, which is the currency of the Ethereum network. The crypto wallet is connected to one of the nodes in the network by design. As transactions enter the network, so imagine I submitted a transaction on my wallet to send 1 Ether to my friend Jeff. these nodes begin to talk to each other, something known as gossiping, to keep each other in sync so that every node is aware of all the network's incoming pending transactions at a given moment. To be clear, these transactions entering the network are not official yet. Transactions enter the network in a pending state through any node in the network, and these transactions are propagated across all the nodes quickly. These pending transactions sit in each node's memory in a kind of pool known as the mempool. Every node on the network has a mempool containing all of the same pending transactions. Through another set of rules specified in the blockchain network's protocol known as a consensus mechanism, the nodes eventually come to a consensus on the next group or block of pending transactions to officially add to their canonical records, of which an identical copy is retained by every single node. This copy of records, representing the history of transactions on the blockchain, is known as a ledger. So one question you might have is, well, why don't we take all of the transactions waiting in the pool for each block? Why do we just take a subset? So the answer is that blocks are intentionally set at a limited size, where size can be defined as the number of transactions that can fit into one block, because the larger the block size is, the fewer computers that can handle the storage and computation required to process these transactions, and so the less decentralized it becomes. And a blockchain depends on decentralization for resiliency. The more nodes that are running the software, effectively the more clones the Ethereum network has, and the more difficult it is to shut down the network. Another question you might ask is, well, why would anyone run a node to help process blocks of transactions? And the answer is because you get rewarded by the system for processing blocks. In Ethereum, when you process a block as part of the protocol, the network mints ETH, or Ether, in the same way that the Fed can print money out of thin air and gives it to the node that processed the given block. By the way, these nodes are often referred to as miners because ultimately they are only running the software in order to pursue the reward of Ether, but I personally find the mining analogy a bit confusing, so I stick to calling them nodes. Okay, so now imagine a set of transactions gets selected by one of the nodes to be the official next block of transactions. So imagine one node selected those 4 transactions. The scroll icon I have there is to depict an official block of transactions. That official block of transactions will then propagate to all nodes on the network like so. Notice how each node has the exact same running copy of the ledger. All the computers run in identical fashion and have an identical copy of the ledger, so that everyone is in full agreement about the current state of the system. So at this point, we know that a blockchain network is just a group of computers where each computer is running the Ethereum software, and in doing so, collectively processes transactions on the network in a series of blocks and stores this series of blocks in its database. The stored chain of blocks, which lives identically on every node in the network, is called a blockchain. Again, this is sometimes called a ledger, since it is effectively a chronological ledger of all the transactions made official by the Ethereum network. So if we zoomed in onto one of these nodes' databases, you would actually see the blockchain. You will first see block 1, followed by block 2, followed by block 3, etc. All of the blocks in this series contain a reference to the previous block, which is why it's called a chain. And this reference is needed so that we have a chronological ordering to all the transactions that ever occurred in the Ethereum network. Each block gets processed about every 15 seconds, and Ethereum, which started in 2013 on block 1, is currently around block number 13 million. The process of network computers gathering all incoming transactions into a pool, coming to consensus on the next group of transactions to publish, publishing them, and then consequently updating the state of the system happens at a regular time interval. This regular time interval creates a kind of network heartbeat, where each 15 seconds for the Ethereum network, a new block is added to the chain, and the state of the system is updated to incorporate the content of this new block of transactions. And every node running will update their copy of the blockchain, aka the system state, into their local database such that all machines have the exact same state. Now we know that the purpose of a blockchain network is to produce official blocks of transactions which update the shared state of the system. but who gets to choose what transactions go into the next block? This idea of deciding who gets to choose is something that different blockchains do differently, but this process of a network of nodes agreeing upon the next block to accept as canon is called the consensus mechanism. That is, in order for any blockchain to work, you need a mechanism that all the nodes in the network can agree is legitimate for determining the next group of transactions that will be packaged into a block and added to the running blockchain. You might think that one way to do it is to pick a node at random and let that node decide the next transaction block. So first it's this node, then this one, and then this one. But there's a problem with this. The problem with this strategy is unless every node is acting honestly, this isn't going to work, and here's why. Say the network has only honest actors, and that this one here got to pick the next block. After he is chosen, he communicates outward to the other nodes the new block of transactions that the network should make official. Since all the other nodes are good actors in this scenario, they honestly propagate out this new block announcement. Every node is in agreement about which block to process next, the network runs smoothly, and consensus is reached. But now imagine that some of these nodes want to sabotage the network. And when the honest chosen node sends out the block announcement, they do not relay this message. Instead, these dishonest nodes could broadcast a different block containing a different set of transactions. So now all the nodes in the network are receiving conflicting information for what the next official block is. So how is this resolved? The answer is a design mechanism called proof of work. This was a groundbreaking invention first proposed by an anonymous or pseudonymous individual named Satoshi Nakamoto in the 2009 Bitcoin white paper. Picking a node at random doesn't work because it is very easy these days for a single individual to spin up thousands of remote virtual nodes through their laptop at a very low cost. If that individual were malicious, using a system of random selection, they would end up being selected the most often and could overtake the network by announcing blocks which only benefit them, making the network undesirable to use for anyone else. So instead of picking a node at random, blockchains like Bitcoin and Ethereum use a consensus design called proof of work. Proof of work is based on an important assumption, that the majority of all distinct actors on a network will be honest. If you accept this premise, then what you need is a mechanism to ensure that whoever gets chosen must be from the honest majority, not the dishonest minority. The way proof of work works is there is a pool of pending transactions sitting in the mempool, and every node must compete to solve a math puzzle, where this math puzzle relates directly to the specific bundle of transactions from the mempool that any node wants to include for their next block. Side note, anytime you submit a transaction, you can add a tip which goes to the nodes to increase the likelihood of your transaction getting included in the next block. Most of the honest nodes are going to try to solve the puzzle for the same transaction bundle, because most nodes sort transactions by the tip amount, resulting in an identical ordering. For example, say node 1 sorts all the transactions in the mempool by tip, bundles the top 10, and then tries to solve the puzzle for that bundle. Most of the other honest nodes are doing the same thing, since it is the profit maximizing approach. But what does it mean to solve a puzzle? In short, it's just guessing the numerical input to a function such that the output equals some numerical output. So if you remember back in algebra class, when you got a math puzzle like f of x equals 13 plus x, find an input value x such that f of x equals 20. This is an example of the kind of puzzle these computers are being asked to solve, only they are several billion times more difficult. It's also the case that the output value is dependent on the content of the chosen transaction bundle, meaning a given node must solve a specific puzzle that corresponds to a particular bundle. It turns out that solving this puzzle cannot be done intelligently. It is designed in such a way that it requires random guess and check. But the more processing power you have, the faster you can guess and check, meaning the amount of processing power that you have directly corresponds to the amount of times you will be chosen. If you have 100% of the processing power of the network, you will always solve the puzzle first, of course, and the transaction bundle whose puzzle you solved will become the next official block. If you have 10% of the processing power of the network, you can expect to solve the puzzles about 1/10 of the time. Now, let's think about the network just in terms of two groups, the honest nodes and the dishonest nodes. Whichever group out of these two has 51% or more of the processing power, this is the group that will solve the puzzles most often. And those who solve the puzzles get to determine what the next block is. And the beauty of this seemingly arbitrary, compute-intensive puzzle design is the fact that it requires processing power, and processing power requires money. And having enough money to acquire 51% of the processing power of the network is now prohibitively expensive, somewhere in the tens of billions of dollars, and increasing by the day. Meaning, unless a group of dishonest collaborators are willing to spend tens of billions of dollars to gain the majority of the network processing power, the honest nodes will win out, and the system's integrity will be preserved. So here's a little animation of one of the nodes winning by solving the puzzle. The others are losers. And that winning node will get to present its block of transactions as the next official block, and that will be added to every node's blockchain. So that winner is the one who gets to make the next official block. And one question you might ask here is, well, if 49% of the network were dishonest, wouldn't they win the game at least some of the time? And the answer is yes, they definitely would. So to counter this, when a node hears about a new solved block, it won't consider it final immediately, because the new block they're hearing about may be the result of a dishonest node getting lucky. If this happens, there will be a temporary divergence in the blockchain, where two different chains are competing to be recognized as the real chain. So imagine you have one official block, and then the next block is now being worked on by the various nodes in the network. Imagine that the dishonest faction gets lucky and is able to solve for a block at the same time or even slightly earlier than the honest faction. At this point, the network is in a state of confusion about which chain should be the canonical chain. The dishonest minority is working on their own chain. Remember, different blocks mean different proposed transaction bundles to represent the next set of events in Ethereum history. And blocks with different transactions require the solving of different puzzles. So now you have a situation where one group, the dishonest group, is focusing all of their compute resources into solving puzzle A, and the other group, the honest group, is focusing all of their compute resources into solving puzzle B. But in fact, the problem compounds, because when there are competing chains, the network strategy is to simply lay back and wait, and let subsequent blocks be built on top of the two competing chains. So even if the dishonest group gets really lucky, and say processes the second block at roughly the same time as the honest group, because the dishonest group is, we assume, the minority, and therefore has less computing power, this will eventually manifest in the honest version of the chain significantly outpacing the dishonest version of the chain. You could think of it sort of like a coin flip, which has a 51% weight to heads, where heads represents the honest majority, and a 49% weight to tails, where tails represents the dishonest minority. If you flip the coin once, you definitely might see a tails. But if you flip the coin long enough, the inherent weighting of the coin is going to manifest, and you are eventually going to have, by definition, 49% of the flips be tails and 51% of the flips be heads. So as you can see, the group with the majority of processing power is going to outpace the minority when it comes to solving a chain of puzzles. And since we're assuming the group representing the majority of processing power is honest, then we now know which chain to make official, this one. Now, this very clever consensus mechanism has a flaw, which is that because it is so compute intensive, it uses tons of electricity, some of which comes from sources which harm the environment. Luckily, there is a more modern consensus design mechanism, and while Bitcoin is not likely to move to it because the Bitcoin developer culture is conservative and resistant to change, which is another topic entirely, Ethereum will be moving to it next year. Instead of being called proof of work, it's called proof of stake.
I think there's been a mistake.
Did you say steak?
No, mistake.
Oh, see, now you got me all excited.
In proof of stake design, the idea of utilizing processing power is scrapped for just using economic resources, which the processing power design was always just a proxy for. Ultimately, both designs leverage the fact that a minority of dishonest individuals cannot produce more economic resources than the majority. In proof of stake, every node must lock up or stake a certain amount of Ether, the currency of Ethereum. And every 15 seconds, a random staked node is chosen to propose the next block and broadcast it to the network. If you simplify this again to two parties, a dishonest minority and an honest majority, assuming all individuals have roughly the same economic resources, the honest majority is going to determine whether to accept or reject the next proposed block. So, to recap, a blockchain is a protocol or set of rules implemented as open source software. This software can be run on any computer, including your laptop. Each computer running this software is referred to as a node in the network. When this software is run, all nodes begin listening for incoming transactions on the network. As transactions enter the network, the nodes begin to talk to each other, something known as gossiping, to keep each other in sync so that every node is aware of all the incoming transactions at a given moment. Transactions enter the network in a pending state, through any node in the network, and these transactions are propagated across all the nodes quickly through the gossip mechanism. Pending transactions sit in each node's memory in a pool known as the mempool. Through a set of rules specified in the blockchain network's protocol known as a consensus mechanism, the nodes come to a consensus on the next group or block of pending transactions to officially add to their canonical records, of which an identical copy is retained by every single node. These blocks of transactions are organized in a chronological chain known as the blockchain. After consensus is reached on the next official block, each node updates their personal copy of the network's canonical blockchain, and this updates the global state of the system. Okay, so you might be thinking, great, now I know the mechanics of a blockchain network, but why does this matter to me, and why are people so excited about this? The answer is, for the first time in recorded history, humans have invented a way to have a flat, leaderless, resilient, state-capturing system where parties don't have to trust one another because the system itself is designed in such a way that anything that a participant does on the network can be trusted to work as expected. We are currently living in a world where data and state is siloed. Each company has its own data, and that data, which you can think of as value or assets, is often guarded and made difficult to move across domains of the internet. So, for example, your Facebook pictures exist on Facebook servers, and there is no way to seamlessly port those photos over to another platform. And this is intentionally done because Facebook makes money by making you dependent on their platform for accessing a particular asset of value, which are your photos. Now, with blockchain, there are no silos. Any piece of data or value that lives on the Ethereum blockchain is visible and accessible to any node on the Ethereum network, as all transactions on Ethereum are stored by every node in their respective database. This shared access and shared state lends itself to a frictionless economy of value. Instead of a world of many companies with many different private databases, you have one global public database, which removes all friction to the process of data exchange and therefore value exchange between parties. Essentially, this is a massive, massive upgrade in the degree of fluidity that our economy can have. Second, we are also currently living in a world where we pay a premium for trust. So for example, when I used PayPal just the other day to receive funds from an international transfer, they took a 10% cut. And I'm willing to let them take that cut because I trust their service more than any other payment platform. At the end of the day, though, PayPal is just a group of humans that have built this trust over many years and now leverages this advantage by charging me for it. This phenomenon is omnipresent throughout our entire current economy, where massive cuts go to middlemen who charge us extractive fees for a guarantee of the successful execution of our requested transactions. Think of all the cuts that companies like MoneyGram takes from remittances sent by immigrants to their families back home. Now these immigrants have an alternative, which will result in a meaningful financial improvement in their lives. With the invention of blockchain, the trust component is built into the system itself. It is written in code that has been battle tested for a decade now. The implication here is all transactions processed on the blockchain will have zero trust fees, which makes doing business on the blockchain significantly more capital efficient and therefore incredibly attractive relative to the current system. I should also mention that because blockchain implementation like Ethereum software is simply code, it doesn't sleep. It doesn't close on weekends. It doesn't make you wait 3 business days to complete your transaction. It is near instant 24/7 value exchange. Third, for the first time in history, we have a global system of shared state with assurances of longevity. That is, it is hyper-resistant to attack and cannot be stopped. There are tens of thousands of nodes running Ethereum software around the world now, and this number is increasing daily. The system is not bounded by borders and lives outside of the nation state. Shutting it down would require a global, coordinated effort among nations. It is about as practical as globally shutting down the internet. The benefit of having a system like this is now you have, for the first time, the ability to transact value with anyone on the planet that has an internet connection on an ownerless, credibly neutral system, and can feel assured that it will be here a month from now, a year from now, and even decades from now. So I hope you can now walk away from this feeling like you understand blockchain technology. There are 2 other topics which, combined with this lecture, will make you a crypto expert. The first topic is understanding crypto wallets, how they work, how to create your own, and how to send and receive crypto to someone else who has a digital wallet. This is the most basic and perhaps valuable application of blockchain technology. Bitcoin invented this application on top of the invention of blockchain. However, there is so much more that you can do with blockchains once you've solved for wallets. Bitcoin hasn't moved much beyond wallet functionality, but Ethereum is much, much more. And this leads us to the second topic, which is understanding the richer, more creative applications which are being built on top of wallet technology, which is built on top of blockchain technology, and how you can directly benefit from them. If blockchain technology is a brand new theme park, then it's only natural that we learn about the various rides that some incredibly bright people in the space are currently building on top of it. So I hope you've enjoyed this. If you have questions, feel free to drop a comment below. Otherwise, I will see you on the next lecture where I will be covering crypto wallets. And now I give you Homer Simpson buying crypto.
I'd like to withdraw my life savings, please. And hurry!
Sir, this is a joint account. You'll need your wife's signature, too.
Oh, yes, of course. Yeah, she's behind that plant. Hello, Marge. Hi, homie. Sign this, please. You're the boss.
Daddy, ask the man for some candy.
No candy for you.
Then at least get some candy for yourself.
Kids.
Here's your candy.
So long, sucker!
Sir, your life savings?
Yes, I see that it's in bill form. Excellent.